Assalamualaikum and hi students. Today we are going to discuss chapter 2, which is Kinematics of Linear Motion. Learning outcome for subtopic 2.3 Projectile Motion is describe projectile motion launched at an angle theta as well as special cases when theta is 0 degree and theta is 90 degree. What is projectile motion? Projectile motion consists of two components, which are horizontal and vertical components. The acceleration for horizontal component is 0, and the acceleration for the vertical component is negative g. There are three examples of projectile motion classified by angle. First picture shows example for angle with theta equal to 0 degree. Second picture shows example for angle between 0 to 90 degree. And the third picture shows example for angle with theta equal to 90 degree. What is free fall? Free fall can be defined as the vertical motion of a body at constant acceleration g under gravitational field without air resistance. Does the example shows free fall? Yes, it is free fall. Free fall acceleration, known as acceleration due to gravity g. The value of g is 9.81 meter per second square, and the direction is towards the center of the earth, means downward. Let's say a ball is released from a certain height. The symbol for initial velocity is u, and the final velocity is v. And for displacement is s. Remember, the displacement is measured from initial point to final point. Example of free fall. An object is thrown vertically upward. At position A, the initial velocity is u. When the object is moved upwards from A to B, the velocity is positive and the displacement also positive. At maximum height, which is at point B, the velocity of the object is 0. When the object moves from B to C, the velocity is negative. At position C, the displacement is 0. Let we test our concept understanding. Explain the motion of object from point A to E. Your explanation must include displacement and velocity. Oops! Post your answer in Google Classroom. Next questions. Check your answer in tutorial class. Free fall equations. The table shows the comparison between linear motion and free fall motion equation. We use the same equation of linear motion, but we replace the acceleration A with negative g in free fall equations. Imagine we kick a ball. The ball moves in a trajectory motion. At point A, the ball moving with the initial velocity u. Since the velocity is a vector quantity, so the velocity is needed to resolve into x component and y component. At point P, the ball moving with the velocity v1, which have v1x and v1y. At this point, the time travel is t1. At point B, which is at maximum height, the velocity Vx equals to ux and the velocity Vy equals to 0. At point Q, we did the same process as point P, which is the time travel is t2. At point C, the displacement is 0 because the ball has returned to its original position. The velocity at point C is v, which is final velocity, and have component x, vx, and component y is vy. Sx is the distance between initial and to the final position of object. And for the total time travel from A to C is called flight time. Let we test our concept understanding. From this example, what is the value of Sy? The answer is 1.05 meter. Projectile equations. For the x component, Ax is 0, and for the y component, Ay is negative g. Thank you for your time. See you next time. Bye.